Hello everyone! In a few minutes you will know how to interact with the Algorand blockchain via PLCs. PLCs stand for Programmable Logic Controller, and these are industrial computers. They are quite resistant and they are also hard real-time systems. Therefore, they are perfect for industrial applications. In this video, I will show you how you can make even somewhat outdated controllers communicate with the Algorand network, and that with very little effort. We purposely used an older Siemens control system for this solution. The reason for this is as follows. In industry, machines often have a service life of 20 years or even more. Therefore, it was important for us to show you how even such systems can be easily upgraded to work with the Algorand network. So let's jump into the solution, where I will show you the main functions. The code for this work is linked in the video description. With this video and the files, you should be able to set up your own system. First of all, we have a look at the main function. It's written in the OB1. And in the OB1, we have the cyclic execution, and we just call our functions. The first function is the fun algo. That's the function where the magic happens, and the overhead FC is just a small function I've written for the concept of the visualization, because we have to simulate the die-cast change, and we want to do that without an actual machine where we have to change the stamping tape, and here we can trigger a new change and simulate that. The fun algo function is written in STL, and it contains the function itself, which calls the function block in the space of PLCs. You often work with function blocks because here you have static variables, and therefore you are able to implement some sort of state machine, which quite helps you with the cyclic execution, because normally you have a dozen of function blocks running, and you don't want to use while loops or something, because you have to stay in the hard real time, and therefore you don't want to have that behavior that one function could block another by waiting on something. And this function block basically waits if there is a booking request, which means that the machine user, the operator, has changed the data tape which is showed to him, which is empty, and confirms the change if it was correct, which means it matches the QR code. Then the next state is triggered, which sends the send request to the PC where the Algorand transaction happens, and then it waits for the result, which is written back by the PC to the PLC. The rest is the overhead function, which is just used for the visualization to make buttons or text areas visible or not, depending on the state of the transaction. It was just a nice gimmick for this tutorial, for this video solution. And this is the data block corresponding to the fun block algo. Here are the internal variables of the fun block saved, and the GD algo is our main data block for the transaction, for the communication to the PC. Basically, we have a Boolean variable send request, where we can tell the PC we want to send some algos, and we have a send response where we can get a response back from the PC to tell us which error code has occurred or has the transaction been successful. And what we also can send is the part idea of the thing we want to change at the machine, and also a part name limited to 30 characters. In the space of PLC, you always have to tell the system how long a string can be. So what also is important is this FAT algo table. Here we can force some variables in the PLC. Let's connect to the actual variables with the classes symbol. So here you can see like the actual variables running in the system right now, and with control 0 and control 1 you can force some variables here, which is important for this tutorial. We don't have actual machine, or you don't have an actual machine, and so you can just say datape ID 1 should be changed, so force a 1, and also I force the QR code because you don't have a reader at the machine, because you only have the PLC running. Yeah, that was basically the part of the PLC. So let's load everything into the system by pressing the load button, and then we just confirm everything. And afterwards we are asked to set the system to run again, and we also do that, of course, and then everything is ready for the next steps. So last thing we do is to confirm that the system is running. We go to target system and to the state of the PLC. It's running, so everything is perfect. Now we can start with the other stuff. Now we open the visualization with the WinCC object, and here you can see a very simple visualization for the PLC. It's basically plug and play with WinCC. You have your button boxes, your text boxes, and you just configure them with the right variables from the PLC. So it's pretty straightforward, and we don't cover that process too much, because I'm sure you will figure out to make small changes to it if you want to. So for the solution, we just run the visualization, the runtime, by going here and press this button, and then our runtime will open. Before we jump into the visualization and the actual usage of this solution, of this programming guide, we quickly cover the part and the code on the PC side, where we have a little Python script running. Basically in the main we connect to the PLC with a Snap7 library. With this library we are able to communicate via the S7 protocol, and you only need three things. One thing is the IP address, then another one is the rake and the slot of the PLC. If connection isn't possible, we terminate the program right at the start, because if this can't be executed, it's very highly likely that you have error at your wiring. So please check your connection and make sure that everything sits and everything is in its right place. Afterwards, you just have to specify the right dB number and the right length of it. And in the dB layouts file, you make sure that you have the data structure in the same way as it's at the PLC side. So you can just configure it in that way. And then we have three functions. The first function is a check send request function, which constantly listens to the send request bool bit, and if it's true, part ID and part name is returned, and then we make the transaction and pay the material, pay the stamping tape, and we get back a transaction result, and this result is written back to the PLC, and then everything starts from the beginning. So let's have a look at the function we are using. First of all, the pay material function is pretty straightforward. Depending on the part ID, we choose the send address where we want to send our algos to, the amount of algos, and we fuse together a transaction node where we say that the part name has arrived. Afterwards, we call the algo transaction function. This function is derived from other tutorials from the Algorand developer portal, which shows how good the community already is, because to make such a transaction is really straightforward. You just have to look at the solutions. In our solution nodes, you can also find the right tutorials you need if you want to look into this stuff in more details. But basically we send the address, the amount and the transaction node, and the rest is made by this function. Next is the result to PLC function. After the result, the transaction has taken place, we send the byte array back to the PLC, and this byte array contains an integer. Note that an integer on the PLC, on the CMIM PLC, is only 2 bytes long. And then we write that integer into the DB algo at the PLC, and if that is possible, so we don't get an exception, we say that it is confirmed that it is at the PLC, and we exit this function, so everything has taken place, and the machine user, the operator, knows the code, the return code of the transaction. And last but not least is our function check send request, where we constantly, and with constantly we mean every 2 seconds, we check the bit containing the send request, and if that's true, we return the part ID and the part name. And here it's pretty straightforward. We read all data from the DB algo, and that gives us a byte array, and we translate that byte array to the variables we have defined in this layout file by calling snap7 util.db, and then we can operate with the variables and request, part ID, and everything else. And afterwards we return part ID and part name. So let's start our script and read the data from the PLC, which is already connected and running. First of all, it connects with the library. Now it reads the data. We read from the DB444, which is the DB algo. We see here the byte array, and after that we use that util function with our defined layout. We make more sense of the array because we match it to our actual variables. So let's jump back to the PLC visualization and make the test of the function. So let's have a look at the visualization. The machine operator sees which date type has to be changed, and he can confirm the change by pressing the button. In the background, the Python script is running, and if the operator says he wants to confirm it, he presses the button. In the background, the running Python program recognizes the send request, and here we have our transaction ID, and it also waits for confirmation, and confirmation is given, and the return code is sent back to the PLC, and it was a success. So last but not least, we want to view our transaction at the testnet. We paste the transaction ID into the search bar and execute the search. So the amount 777, that's right. So let's have a look at the node. Diecast number 657 has arrived, so that was our transaction, and that's basically a simple solution to connect a Siemens PLC to the Algorand blockchain. I hope you have enjoyed it and have a good day. Bye.